Okay, here is problem number 8 from homework 5, and hoping this helps you in your studies for your exam. It says to calculate the bit rate of the FDL link in a TDM signal using the ESF frame format. The ESF frame format is a extended superframe. And what they did was they started off with a DS1 frame and said, you know what, we've got too much overhead there. We've got a framing bit every 193 bits. And so we made this 1.544 megabit per second signal out of 24 bytes and one framing bit. Well, what you can do is you can say, you know what, we don't need as many framing bits. We don't have to have a framing bit as often. And what we're going to do is we're going to put 24 DS1s, DS1 frames into a larger frame structure. Okay, and what we're going to do is we're going to use the odd bits. Well, here, let me just show you the slide from the lecture. What we're going to do is we're going to put 24 DS1s into a larger structure. The odd numbered DS1s, those framing bits are going to be used for a data link between the nodes, and it's called the FDL. So we're going to use, and this allows the two sites, A and B, to talk to one another. Half the framing bits from even number frames are used for framing, and the other half the framing bits from the odd number bits are used for error checking. So I'm interested in the data rate of the FDL. And basically, we have all the odd numbered framing bits are used there. And so we're going to have 12 bits from the ESF used for the FDL. And so to calculate the bit rate of that FDL link, I'm going to say, okay, how often do these 12 bits occur? They occur once every 24 frames. And the time for one frame on a DS1 is 1/8000th of a second, or 125 microseconds. And so the bit rate of the FDL link is 12 bits per 24 times 125 microseconds. Or, let's see, 1/2, and 125 microseconds is 1/8000, so I can write 12 24ths times 8,000, or half of 8,000, which is 4,000 bits per second, or 4 kilobits per second. Sorry about that. I think you get the idea. 4 kilobits per second is the rate of data transmission on the FDL link, according to definition. And we can draw a picture of the FDL link here, where we have an odd frame and an even frame, and an odd, an even, etc., an odd, an even, and this would be frame number 1, 2, 3, 4. Finally, there are 24 of them, 23, 24, and the framing bit from the odd ones, the odd numbers. Okay, so this bit, this framing bit, this framing bit, this framing bit, 1, 2, up to 12 of them. We get 12 bits in the time it takes for 24 teeth frame. Oh, there we go. 12 bits in 24 frames. Okay, straightforward. Of course, once you find the place in the slides, it goes over that. It becomes clear. So I hope that helps. Thanks.